Hello, welcome to day 2 of 30 days of Python. So today we'll be doing a bit of theory, some more theory before we actually start looking at the Python programming language in depth. So what is a computer? Now a computer is a machine that processes information under the control of a program. That means that a computer is a machine. You must first see it as a machine. It's not it's no different from a car. But the difference between a car, okay, no, cars are even programmable nowadays. It's no different from a water wheel. The difference between a water wheel and a computer is that a computer can be programmed, but they are both machines. Now, the next thing is programming is the creation of a sequence of instructions that controls a computer. What that means is that you write out the instructions for what you want the computer to do. Now, before you can write out the instructions, you need to understand the problem you're trying to solve. It doesn't matter how difficult the problem is, you need to understand the problem, and then you need to resolve if that problem is what we call computer tractable. That means if the computer can actually solve that problem. Then once you understand the problem, we create a model of the problem we're trying to solve. The model we create will allow us to solve the problem without a computer. Yes, and that's how you test your solution. No matter how difficult it is, you can resolve every problem without a computer. So whenever you give computer a set of instructions, you're programming it. Now, programming language abstraction means that as you go higher, the less machine-like the programming language looks like, and the more it looks like English. So this is it. At the bottom, you have your hardware, you have your switches and gates. On top of them, you have your machine language, which is 0 and 1. On top of that, you have assembly language, you have high-level languages, then you have Python, Java, JavaScript, you have Scratch and App Inventor. Now, Scratch and App Inventor are more for academic purposes. So let's focus on Python, Java, and JavaScript. Now, Python, Java, and JavaScript have English-like syntax. They no longer look like machine language. They have English-like syntax. And that's what I mean by programming language abstraction, meaning that the higher you go, the more you abstract away from the machine, and the more it looks like English language. Now, let's come to a bit of more theory. The executive summary of Python is that it is an interpreted, object-oriented, high-level programming language with dynamic semantics. This means interpreted versus compiled. When you say a language is interpreted, it means that as you run it, the language is executed. Versus when you compile, when you have a compiled language, you have to, like Java, you have to first write the entire code down, then compile it. It has built-in data structures. Data structures deal with working with data. Combined with rapid typing and dynamic binding, we make it attractive for rapid application development, as well as for use as a scripting or glue language to connect existing components together. Python is simple, I agree, easy to learn. Python simple, easy to learn syntax, emphasizes usability, and therefore reduces the cost of program maintenance. Totally agree. Python supports modules and packages, which encourages program modularity and code reuse. When they say modules, there's the built-in Python functions. Then modules are things like maths, things like import this, things like, wherever you see import, you know that you're importing a module and a package. Python interpreter are available in source and binary form without charge or for all platforms and can be freely distributed. Python is open source, by the way, so that's something to keep in mind. Now, the Zen of Python. The Zen of Python is gotten by saying your interactive shell imports this. When you import it, it reads out the Zen of Python for you. My favorite one is simple is better than complex. So a simple solution that works is better than a complex solution that works. Yeah, yes. Simple solution that works is better than a complex solution that works. So always try to keep it as simple as possible. Please, on your own, and type in this command, import this, and then see what it brings out. Now, why Python? We use Python because it is simple, versatile, and has a large community. Simple is one of the simplest programming languages to even set up and install. On day one, we looked at Python setup and installation. Python is one of the simplest languages to set up and install. You don't have to struggle with the compiler like in C++ or put namespaces or add it to path like in Java. Python is versatile. There's a running joke that Python is the second best language for anything. It may not be number one in that domain, but it can still act in any domain. Then a large community. There's nothing you want to try and do in Python that Python cannot achieve. There's nothing you want to try and do in Python that Python cannot achieve. Now, why do we program? According to Eric Hodges, and this is the best definition of why we program. Programming, the purpose of programming is to build machines out of bytes that are impossible or too expensive to build machines out of atoms. Computers are machines that can imitate other machines. Programming is the act of making them do that. And that is why we program. We program so that we can build machines out of bytes. And I've always said it, the computer is a machine, computer is a machine, the computer is a machine. Now, before we can do that, once you have the problem you're trying to solve for, you create an algorithm for it. Now, an algorithm is a specific step, it's a set of specific steps for solving a category of problems. Now, the algorithm we're going to look at here is called Euclid's algorithm. And these are the steps for Euclid's algorithm. The first step is step one is to ask the user for two numbers. Step two, you test which one is larger. Step three, make the bigger number m and the smaller number n. Step three, set r to the remainder when m is divided by n. Step 1, 2, 3, 4. Step 1, 2, 3, 4, 5. Okay, step 5, set m to n. Step 6, set n to r. Now, if r is 0, the HCF is n, you stop. Else you go back to step 5. Now, the best way to understand this algorithm is to take two numbers, and we're going to take m. Okay, we'll call it first number m. Second number n. R. Let me do this. X, the step number now let's take two numbers to start. You take 1000. Step 1, sorry. Step 1. You take 1000 and you take 6 to 5. Now, the way you find the remainder is not by subtracting. The way you find the remainder is you use what we call the modulus function. The modulus function uses the percentage symbol. So we use the modulus function. So we say 1000 modulus 625. You press enter, you get 375. So that's 375. Come to step 2. You say, now this is the part where it gets tricky. When they say set m to n. So that means you move this way. Set m, the value of m to n. So you move this way, and then you say this is 6. We're going to do this now. So you now say 625 modulus 375 equals to 250. 250. Step 3. 375 250. That will be 375 250 equals to 1, 2, 5, 4, 250 modulus 25. When we do this, that will be 250 modulus 0. The answer is 0. Okay, beautiful. So you see now that the HCF is 125. So using Euclid's algorithm, you can find the HCF of two numbers. I think it's a good place we can stop. So what we'll do is from day 3, we will be looking at writing code in the interactive shell. And using the interactive shell as a calculator, creating scripts in Python, data types, mathematical operators, storing values in variables, input and output. Thank you very much for your time.